Welcome back. The objective of this video is to use our calculator to find a regression model of decay and answer some questions in a real-life example. So here in example 5, we have a chemist that has a 100-gram sample of a radioactive substance. The table below shows the amount of radioactive material at the end of the 6-week period. So we have a decay model, so we know that our R is going to be somewhere between 0 and 1. In our table, our weeks are going to be our X's, and our weight in grams will be our Y's. Now we're going to use our calculator for this, and we're going to go into the stat menu, and we're going to fill out lists for list 1 and list 2 for our X's and Y's, and enter the data into our calculator. So using a graphing utility to fit the exponential function, write the equation for the data. So we're going to go in our calculator under Stat, Edit, and our two lists. We'll turn our plots on. We're going to steal our window from our table, so our X's are going to go between 0 and 6. I'll probably expand that out. And our Y's are going to go from 100 to about 40, and I may end up expanding that out as well. So let's head over to our calculator and start entering the data. So I have my calculator out, and I'm going to go into the Stat menu. So Stat, Edit. I've got some data left in here from list 3 that I don't need. I can clear that out by just highlighting the list, hitting Clear, and Enter, so you know how to clear a list. And now we'll go ahead and enter 0 through 6 in list 1, and then our corresponding weight in grams in list 2. So I've entered my data in list 1 and list 2, my X's 0 to 6, my Y's 100, 90.4, 76.8, 69.7, 58.2, 49.7, 44.2. Looks like I have those all correct as well. So now I'm going to turn my stat plots on. So I'm going to go to Second, Stat Plot. I'm going to turn on plot 1. It looks like I got to hit Enter. I've got L1 and L2, so I'm good there. And now I'm going to take care of my window. So I'm in the standard window right now. My X's go from 0 to 6. I'll go from like -2 to 20. You probably could only go to 10 if you wanted to, but I know there's some other things coming. I'm going to go out as far as 20 right now. And then our Y min, our Y's maybe go to 30, and our Y max, I always like to go a little bit above, so 110. I'll count my Y's by 10. I'm going to go back and correct my scale, my counting for X's. I'm going to count by 2's on that. Okay, and then I can probably go ahead and graph that, and I see my data here. So now I want to find the equation of my line. So I'm going to go back into the Stat menu. So Stat, I go under Calc, and we know that this is an exponential model. So this is an exponential model of decay, and I don't see any exponential in 1 through 9. So I'll keep going down, and 10, 0, exponential regression. So I'm going to do exponential regression is 0. I've got L1 and L2 again. If you don't remember how to change your lists, that's just under blue, and then L3. I don't want L3 though, so I'm going to go back and change that. Second and L2. And then we want to store our regression equation. So remember how to do that. That's under the green alpha, under F4. So I'll go alpha, trace, or F4, and I'll store that under Y1. And now I'll go ahead and calculate my regression. So there's my regression, and I can go ahead and write that in answer A. So our A value, or our initial amount, is 102.306. Now that's based on the model. And our B, our rate of decay, is 0.86926. And then the B is raised to the x power. So I copy that onto my sheet, the answer to A. I don't have any room there, so y equals 1.02306. Now it says, using your equation from part A, what value would represent half of the initial value? So the answer to that first question, half of the initial value, well, A sub 0 is 102.306. So half of that, if I just divide that by 2, half would equal about 51.15. So, and if we look at our original data here at 100 to 50, so about halfway to 49.7 would take about 5 years. And sure enough, how many weeks to reach the half-life of the radioactive material would it take? Well, we figure this would take about 5 weeks, because that is consistent with what our table says as well. So about 5 weeks to reach half of the amount. C says, when will there be 10 grams of material left? So the 10 is our y value. So we're looking for an ordered pair of t or x and 10. So when is our output going to be 10? Well, what we can do here, since we don't have the algebra to do this, we'll graph y equals 10 and find the intersection on our graph. So we got to go back to our calculator and graph y equals 10 and see where they meet. So before I graph y equals 10, here's my original exponential equation. We'll graph that, and sure enough, we got a nice line through our data. And now we'll go ahead and input y equals 10 into our graphing calculator and go ahead and graph that. I see nothing. Well, why is that? Well, my window goes from a y min of 30 to a y max of 110. So 10 is not a y value in my window. So I'm going to have to go down and expand my window to be even bigger. And I'm going to go to like -5. Now I know for sure y equals 10 is going to be on there. I'm going to graph that guy, and there is my intersection of y equals 10. So now I need to go to the intersect menu. So under second calc, I want to find the intersection 5 of the blue curve, enter, the red curve, enter, make a guess, I don't bother, and I just hit enter. And it looks like after about almost 6 years, we will have a weight of 10 grams. So our graphing calculator told us the intersection was at 16.597 for x and a y of 10. Our equation would have looked something like this, where 10 equals 102.306 times 0.8693 raised to the x. We'd have to do logarithms to solve for x, so right now all we can do is use our graphing calculator. Finally, how much radioactive material will be left after 52 weeks? Well, that is a time of 52 weeks, so y equals 102.306 times 0.8693 raised to the 52. I can put that in my calculator and just calculate that, or on our graphing calculator or graph, we can do a value of x equals 52 and just find that out. But keep in mind, our x's have to go to 52 on our graphing calculator. So as I pull my graphing calculator out and look at my window, my x max was only 20, so now I'm going to have to go out to like 55, and now I can graph that, and I can go to second calc and find a value of x equals 52 and hit enter, and it tells me I will have about 7/100ths of material left after 52 weeks, or after 1 year. So putting it in my calculator, I'm going to get 7/100ths, or I'll have 7/100ths of a gram remaining after 1 year. And there's a nice sample problem and some calculator use for you of a application problem of exponential decay. And you'll get some more practice with this when I see you in class.